I pray for the fire to keep moving higher. You know my desire to please you, Messiah. Pray for the fire to keep moving higher. You know my desire to please you, Messiah. The night just is fire, fire. And the glory fire. When the rest is fire, fire. I will be on fire, fire. The night just is fire, fire. And the glory fire, fire. And the rest is fire, fire.
So the topic we're looking at today is indices, but it's going to be involving quadratic equation. Indices involving quadratic equation, or let's say quadratic equations involving indices. So the root base is indices. So I want to believe you've been taught indices, and I want to believe you also have been taught quadratic equation in your junior school. So I'm going to be starting right away, sharing the white screen with you as we have the topic and the question. So indices involving quadratic indices involving. So you can try to put down the details as you listen along, because that is because you've been taught also. So that's why. So indices involving quadratic equations. So, but just in case you need to ask any question, you can unmute yourself, signify, and ask such a question. So indices involving quadratic equation. That's what we're going to be starting with now. And first question we're going to be looking at is just purely, indices. So let me just put this straight and say we're going to be looking at the first question. So Zukia, you are welcome. As soon as you join, mute yourself so that okay, that's okay. The topic you can see on the screen is indices involving quadratic equation. So you've been taught indices before in this SS1 lesson, and you have been taught quadratic equation from your junior school. So that's why we're going to be looking at some questions right away and see how to solve. So let's look at examples now. You can put down your notes as I write, because this is what you've been taught. But if you have any question, you're going to just mute yourself and signify. Or mute yourself and signify, then you ask such a question as we move along. First question I have here says 3 raised to power 2x minus 3 raised to power x. Let me try and see this clearly. So 3 raised to power 2x minus 3 raised to power x plus 1 minus 4 equals 0. So 3 raised to power 2x, I'm going to write that down. So let's see. Question 1. 3 raised to power 2x. Here now, you want to subtract, so minus 3 raised to power x plus 1 minus 3 raised to power x plus 1, then minus 4. Minus 4 equals 0. Minus 4 equal to 0. Yeah. Looking at this, since it is minus or true or plus, when you encounter minus or plus in indices like this, and you can't just add and you have unknown, the first bet is to go and solve for the unknown. Yeah. You're just going to look at it and say, we have something like, you can split this, you can split this into the power base and say we have 3 raised to power 2x minus 3 raised to power x times 3 raised to power 0, 3 raised to power 1 rather, because in indices, when you are multiplying, that's when you add the powers together. So one here is having a base which is times 3 raised to power 1. So in indices, when you're multiplying, you just pick one and add the power together. So minus 4 equal to 0. So here we can now say 3 raised to power x all squared, then minus this 3 raised to power x into 3. 3 raised to power 1 is 3. So minus 4 equal to 0. Please make sure you focus on this. I don't want to see the wall of your room but your face. It's your face that should be showing, not the wall. Now, here now you have 3 raised to power x here, 3 raised to power x here. Then you can say let any letter, like Z or A or B. So let Z equals to 3 raised to power x. So that means anywhere you see 3 raised to power x, you put Z. So this one becomes Z squared minus 3Z minus 4 equal to 0. So this becomes Z squared because it said anywhere you see 3 raised to power x to Z. So this is Z, all Z squared. Then this is 3 of Z, 3 times GZ, that will be 3Z, then minus 4 equals 0. So this becomes a quadratic equation. At this point, if you don't know how to solve quadratic equation, that is another question. But this is no longer indices for quadratic until you solve the quadratic. Now, how do you solve this? Look for two numbers to multiply together to give you this negative 4, and you add together to give you this negative 3. And those two numbers are 1, positive 1 minus 4 gives me negative 3, and positive 1 times minus 4 gives me the negative 4. So I'm using positive 1 and minus 4 to represent these 3 Z here. So I have Z squared plus Z, which is positive 1Z, minus 4Z, then minus this 4 equal to 0. So with that, you can come up and say, I have these two sides. What's common to these two sides? I have Z common, so I pick Z outside into Z plus 1. And what is common to the other side? I have minus 4 is common. So minus 4 into Z plus 1 equal to 0. So then I have these two sides. Z plus 1 is common, so I have Z plus 1 into Z minus 4 equal to 0. So this means this bracket times this bracket equals 0. So if you are multiplying two things to be 0, A times B equals 0. Under what condition can that be? Either A is 0 and it multiplies the number B to be 0, or B is 0, multiply the number A to 0, or both of them are 0. So you can say the first one is 0 or the second one is 0. That means Z plus 1 equals 0, or Z minus 4 equals 0. That is under the condition that the multiplication of the two can give us 0. So now you have Z here equals to negative 1, or Z equals to 4, or Z equals to 4. So that is the end of that particular quadratic equation, but that has not solved our question to find x. That has not solved our question to find x. So in a bit to find our x, we're going to go back and substitute the value of z in this place. So here now, we have two situations to face. Let me circle this. We have two situations to face. Situation where z equals to minus 1, or where z equals to 4. So if z equals to minus 1, we're going to choose minus 1. You now say minus 1 because z is 3 raised to power x. You can say minus 1 equals to 3 raised to power x. Or 4, which is the second value of z, equals to 3 raised to power x. So in this case, let's see if there is any correlation, because it's z we're looking for, and our z has been 3 raised to power x. Anyway, in this case, we do not have a root base for x here. Don't have it here. Let me say minus 4. Here, I'm trying to just find. But leading to the quadratic equation, this is the solution to that. But in other realms, we're trying to find the value of x through the indices. So here now, let's see, 3 raised power 2x, which is this. So we can pick our z. Okay, that is it. We can pick our z. If I have the square root of this, then I can't have the square root of 3 to be a perfect. So that means that is there's something wrong with the base. Let's assume it's 2 now. It's going to be 2 square and 2 raised power. So let's look at one other question. But the basic is that if you have indices like this, it's different from indices where you have, let's say you have something like a raised power 5, times a raised power 4, and you know that's just a raised power 9 because you're adding 5 plus 4. That is not what we're dealing with here. We're dealing with index equations here, equations that involve indices or indices that involve quadratic equations. So let's look at a very straightforward example in this one. Let's look at this. Okay, there is another one here. Let's see. Okay, here is one. 9 raised power x. 9 raised power x minus 4 into 3 raised power x plus 1 plus 27 equals 0. So 9 raised power x, we clear the screen. I should put that on there. 9 raised power x, example 2. 9 raised power x, then minus 4 into 3 raised power x plus 1. So minus 4 into 3 raised power x plus 1. Then the third constant, the third term there is plus 27 equals to 0. Plus 27 equals to 0. In the same way, we have negative, we have positive, adding and subtracting when we have indices, 9 raised power something or 3 raised power something. In this way, we're going to find the root, which is 3. The root, the base of this is 3. So I can have my 3 square, that is 3 raised power 2x minus 4 into this 3 raised power x. Again, we have another one here, which is 3 raised power 1. That should have given us x plus 1 plus 27 equal to 0. So in this regard, we can go ahead and use any letter also to represent our 3 raised power x. 3 raised power x, maybe let's say y represent 3 raised power x. So if 3 raised power x equals to y, then we can say anywhere we see 3 raised power x here, we put y. So this is going to be y squared. 3 raised power x is y, then squared, the power that is there. Then this is y. This is 3y times 4, that is 12y. So minus 12y plus 27 plus 27 equal to 0. Please focus on this. So this is also another quadratic equation that we want to solve. We're looking for two numbers to multiply to give you 27, to add to give you negative 12. Okay, factors of 27, we have 3 and 9. So negative 3 times negative 9 gives us positive 27. Negative 3 plus negative 9 gives us minus 12. So I can have y squared minus 3y minus 9y plus 27 equal to 0. So what is common to this side? Y into y minus 3. And what is common to this side? Negative 9 into the same y minus 3 equal to 0. Again, y minus 3 is common to them. So I can say y minus 3 into y minus 9. Y minus 9 equal to 0. Here I can say y minus 3 equals 0 or y minus 9 equals 0. Y minus 3 equals 0, 1. So here you can say y equals 3 or y equal to 9. And this is a straightforward answer relating to our assumption here to say y equals to this. So if y is 3, that means 3 raised power x equals to 3 raised power 1. Then x there will be 1 straight away. But if y is 9, on the second part, that means 3 raised power x equals to 3 squared. 3 squared is 9, then x is going to be 2. So we can say x equals to 1 or 2. And that is the solution to it. And let's see, if we put x to be 1 into this equation, we put x to be 1 into the first equation given. So that means we have 9 raised to power 1 minus this one also raised to power 1. So 1 plus 1 is 2. 1 plus 1 is 2. That means 3 squared is 9. Then 9 times 4 should be 36. So 36, we are saying 9 minus 36 plus 27 should give us 0. Or when we put x equals to 2, you can substitute and check out this. But leaving that aside, this is the answer to this particular question. So you can unmute yourself and tell me, Ezekiel, do you understand this? Unmute yourself and talk.
Yes, sir.
Okay, it's very clear to you. That's it. Now, I'm going to look at one more question, then call it a day for today. So you can put that down while I bring up one other question. Another question, let's see. This is, okay. So 5. Okay, let's see this other one. This one says 25 raised to power x minus 6 times 5 raised to power x plus 5 equal to 0. Or see any one there. 25 raised to power x, let's check that out. 25 raised to power x minus 6 times 5 raised to power x. So example 3. Example 3. Try to undo that. 25 raised to power x minus 6 times 5 raised to power x. 25 raised to power x minus 6 times 5 raised to power x plus 5 equals 0. Make sure that it's minus. So plus 5 plus 5 equal to 0. This time around, you can see 5, 25. So 5 is like the base of all this. I can have 5 squared. 5 squared or 5 raised to power 2x rather. Or let me undo that and write it properly and say 5 raised to power x all squared. So 5 raised to power x all squared, because 5 squared is 25. Then minus 6 times 5 raised to power x plus 5 equal to 0. Here now, you say let p equal to 5 raised to power x, or let 5 raised to power x plus p. Then this one becomes p squared minus 6p plus 5 equal to 0. Yes, equal to 0. P squared minus 6p plus 5 equals to 0. Then here you look for two numbers to multiply to give you 5 and to add to give you negative 6. And what are those two numbers? Ezekiel, unmute yourself and tell me. What are two numbers to multiply to give you 5 and to add to give you negative 6? Yes, Ezekiel.
Plus
yes,
1 and minus 1.
Plus what?
1.
No. Okay, mute yourself. Sure. And you said You said plus 1 and minus 1. No, that will never give us this. Two numbers to multiply give you like a number times the other number to give us 5. Then a number plus the other number, same thing to give us negative 6. So what we will be using here is negative 1 and negative 5. Minus 1 times minus 5 gives us positive 5. And this is positive 5. Then minus 1 plus minus 5 gives us minus 6. So that's what we're going to be using. Yeah, so we're going to be using minus 1 and minus 5. So if we are using minus 1 and minus 5 to replace this, that will become p squared minus 5p minus 1p plus 5 equal to 0. So what is common to this? P into p minus 5. And what is common to this side? Negative 1 into p minus 5. So equal to 0. Then you can have p minus 5 into p minus 1 equal to 0. So you can say p minus 5 equals 0, or p minus 1 equals 0. So p equals to 5 or p equals to 1. So this is our p. P is 5 raised power x. So 5 raised power x equals 5. Or 5 raised power x equals 1. So if 5 raised power x equals 5, that means this is 5 raised power 1. That means x equals to 1. And if 5 raised power x equals 1, that means 5 raised power x equals to 5 raised power 0. 5 raised power x equals 5 raised power 0. That means x equals to 0 in this regard. So you can say x equals to 0 or 1. And that is the solution to that. So I believe that this is very clear to you. So that is where we're going to be ending this summer lesson for this year. But we might need to meet GB during the term. If you have any challenge in any of your studies or any of the questions or the subjects, unmute yourself, please. Let's hear and answer the question. Now, are you intending to go for art or science? That's what I want to get. That's why I say art. Okay. You can mute yourself back. So, whether art or science, whenever you have any difficulty, you can use a chat up and we'll find a way to go around it. So I want to wish you a very successful term as you go. So that's where we're going to be heading today. And I want to say thank you for attending.
Desire,